fx equals to x cube minus 6x cube plus 12x minus 18 is increasing for all x belongs to R that we have to show. Now fx is a cubic polynomial. Fx is a cubic polynomial. So it is differentiable. It is differentiable for all x belongs to R. So f dash x is 3x squared minus 12x plus 12. Now 3 common, x squared minus 4x plus 4. So 3 common, x minus 2 whole square, which is greater than or equal to 0 for all x belongs to R. And therefore, we conclude fx is increasing in R. Phi x equals to x square minus x plus 1. But show it is neither increasing nor decreasing in minus 1 comma 1. So at first we understand that what curve we are dealing with. So x square minus 2x into 1 by 2 plus 1 by 4 plus 3 by 4. This gives us x minus half whole square plus 3 by 4. Now this gives us y minus 3 by 4 equal to x minus half whole square. When you represent this in graph, y, this is origin, this is y prime, x prime, x. Now here is the upward parabola which participates at the point half comma 3 by 4. So the graph look like this. Okay, now this is the vertex. At first, this is the vertex point which is corresponding to half. Comma 0. Then up to 1. So when the input is 1, it is half. So that time output will be what? Output will be 1 by 4 plus 3 by 4, that will be 1. So corresponding to x equal to 1, this output and at x equal to 0 output will be same. Now this will take us minus 1. Now here we take 2 points. One is x1, one is x2. That is, and the abscissa is x1 is x2. And here we have x4. Now, how we have selected the point? We have selected the 2 points on the left of x equal to half. Why? Because here when the values of x is increasing, we can clearly understand the value of y is decreasing. And here you can see clearly it is decreasing. Now corresponding to this one, if we take the corresponding to x3, which will be y3, and corresponding to x4, we have here y. Now here what we understand that as the values of x increase, the values of y is decreasing. Here what you see as the values of x increases, values of y is increasing. So write down when x2 greater than x1, this implies y2 less than y1. And when x3 less than x4, this implies y3 less than y2. The first part, when x2 greater than x1, y2 greater than y1, this part is showing the function is decreasing. And here, when the values of x increases, values of y is increasing. If you take half, this half line on the left hand side, it is decreasing. On the right hand side, it is increasing. So these diagrammatic representation is very, very important. You cannot do it randomly. And here, when I have taken the points have not been taken randomly. This x1 is here, x2 is here. Now both are less than half. x1 and x2 both are less than half. So what we observe here, when x2 is greater than x1, y2 is less than y1, value decreasing. And when x3 is less than x4, you can see y3 is less than y4. So what this part is showing, the value is increasing. So in a particular interval, we cannot have two different nature. Now see the writing part, how to write. So first of all, we say we take x1 comma x2 belongs to minus 1 comma half, such that x2 greater than x1, which implies y2 less than y1 from graph. And when x3 comma x4 belongs to half comma 1, such that x4 greater than x3, which implies y4 greater than y3 from graph. Now, from the first part, it seems that function is decreasing. That is from the first part, this part, what we say, function is decreasing. And from second part, function is increasing. As nature it shows it is decreasing, and this nature shows it is increasing. But if you combine these two cases, because in one part it is decreasing, one part it is increasing, it cannot be. So when we combine these two cases, we cannot conclude anything. Because here it does not have a definite tendency. This part it is decreasing, this part is increasing, so write it down. So over the whole open interval, minus 1 comma 1, fx does not have any definite tendency for increasing or decreasing. And decreasing. Hence, fx is neither increasing nor decreasing in minus 1 comma 1. Now we'll come to the next explanation. Here the function which we have, phi x, is a polynomial of degree 2. Is a polynomial of degree 2. So it is a differentiable function. So it is a differentiable function. Now phi dash x is 2x minus 1. Now when phi dash x greater than or equal to 0, phi x is increasing, which is for x greater than equal to 1. And for phi dash x less than equal to 0, phi x is decreasing. That is 2x minus 1 less than equal to 0. X less than equal to 1. So both the nature is in this interval. So no definite tendency, so not neither increasing nor decreasing. Fx equals to 4x cubed plus 6x cubed minus 24x plus 1. Now what do you observe that fx is a cubic polynomial. Fx is a cubic polynomial. So it is a differentiable function. So it is a differentiable function. We differentiate and get 12x cubed plus 12x minus 20. So 12 if we take common, x square plus x minus 2. So 12 x square plus 2x minus x minus 2. 12 x into x plus 2 minus 1 into x plus 2. Now this gives us what? 12 x minus 1 into x plus 2. Now we take a number. Minus infinity plus infinity. Minus 2 plus 1. Plus or odd sign changes or odd sign changes. Now what we can see that it is decreasing in this interval from minus 2 to 1. So what we can see, for all x belongs to minus 2 comma 1, f dash x is less than equal to 0. Therefore, fx is decreasing in this interval. Now, if fx is decreasing in this interval, it is definitely decreasing in any subinterval. That means in any subset of this one, in that region, fx will be decreasing. So, according to question, f dash x less than 0 for all x belongs to minus 2 comma 1. Because if you want to answer according to question, then we have to see this one, this interval, minus 2 comma 1. Here f dash x is decreasing. Why? Because f dash x is less than 0 here. So we write therefore fx is decreasing. Hence, fx equals to x minus 1 e to the power of x plus 1. Show that fx is positive for all x belongs to x. Positive means fx is greater than 0. Now for this question, we have to understand that when the function is strictly increasing, you can extend the domain when the function is continuous at that time. So here what we can see is a differentiable function. Why? If you think this one as gx plus hx. Now here gx equal to x minus 1 into e to the power of x, which is a product, of x minus 1, that is a linear polynomial, and an exponential function. An exponential function. Therefore, it should be differentiable. It is differentiable. In R. Now, hx is a constant function. Constant function. So, it is differentiable. It is differentiable. Okay. Therefore, fx, which is the sum of two differentiable functions, should be differentiable. Should be differentiable in R. Now, if we differentiate f dash x, what is it? X minus 1 e to the power of x plus e to the power of x. It is x into e to the power of x. Now, for all x belongs to 0, infinity, x into e to the power of x greater than 0. This implies f dash x equal to x into e to the power of x greater than 0. Therefore, fx is strictly increasing. Fx is strictly increasing for all x greater than 0. Now, fx is continuous at x equal to 0. Therefore, we can say fx is strictly increasing for all a's belongs to 0, infinity. And this implies f of x greater than f of 0. Now, what is f of 0? If we find f of 0 here, what we get? It is 0 minus 1 into e to the power of 0 plus 1, which is 0. Now, this shows fx is greater than 0. Prove that the function is increasing in the interval this. So, we take the function as fx. You can say that let fx equals to 5 plus 24x plus 3x squared minus x. We have to show this is increasing when x is less than 4 greater than minus 2. Now, it is a cubic polynomial. Fx is a cubic polynomial. Hence, fx is differentiable function. Now, if we find f dash x, what we get? Minus 3x squared plus 6x plus 24. If we take minus 3 common, x squared minus 2x minus 8. minus 3, x square minus 4x plus 2x minus 8, minus 3, x into x minus 4 plus 2 into x minus 4. So minus 3, x minus 4 into x plus 2. Now, if we take a number line, so from minus infinity to infinity, minus to 4, minus power or sign changes, power or sign changes. Generally, we start with the plus sign, but here with the minus sign because there is a minus sign in front. So minus here, this is coming from this factor, so power or sign exchanging, minus 2 from this one, power or sign exchanging. So from this, what we can say, for all x belongs to minus 2 comma 4, f dash x greater than 0, and therefore fx is increasing. If even it would have been from minus 2 to 4, then also it was possible because f dash is greater than equal to 0 in that level. Either greater than 0 or equal to 0 for function to be increasing when f dash takes. It is a differentiable function and f dash takes either greater than 0 or equal to 0. Then what we say function is increasing. F of theta equal to theta sine theta plus cos theta. We have to show that f of theta increases steadily as theta increases from 0 to pi by 2. That is, we have to show that this is increasing when theta is increasing from 0 to pi by 2. Now, this is a differentiable function. Sine, cos, both differentiable, theta is differentiable, so it is a differentiable function. So f of theta is differentiable. Is differentiable. Why? Because as we have sine and cosine function here, so we differentiate this theta cos theta plus sine theta minus sine theta. That gives us theta cos theta. Now, for all theta belongs to 0, pi by 2, theta cos theta is greater than 0. Therefore, f dash theta greater than 0. Now, function f of theta is differentiable function and f dash theta greater than 0. So, by combining these two concepts, what we can say, that is what we mean to say, that since f of theta is differentiable, function and f dash theta greater than 0, so fx is increasing. Fx is increasing. Here we could say even strictly increasing also. It is strictly increasing function. It is strictly increasing function. For all theta, why we can say increasing function? Because for all theta, this is greater than 0. F dash theta greater than 0, so it is strictly increasing function. Okay. F of x equals to x plus 2 e to the power of minus 6. And we have to find the interval where it is increasing and decreasing. Now, we can see it is a product of fx is a product of linear function and exponential function. So it is differentiable. It is differentiable function. Why? Because both linear and exponential. Why differentiable? As both linear and exponential function are differentiable. Here both linear and exponential functions are what? Differentiable. So it is differentiable. Now this gives us what? A dash x equals to x plus 2 derivative of e to the power of minus 6 plus e to the power of minus 6. Now, after simplification, what we get? E to the power of minus 6 common, minus 6 minus 1, minus 2 plus 1 minus 1. Now, this on taking minus common, x plus 1 e to the power of minus 6. Now we take the number line. Minus infinity plus infinity. Here it's minus plus. You can see that exponent function is always positive. There's a minus outside, so this will be multiplied with this one and you'll get a minus. Power or sign will change. So what we can say here, support A, for all x belongs to minus infinity comma f dash x greater than equal to 0, and it is a differential function. Therefore, here function is increasing. And B, for all x belongs to f dash x less than equal to 0. Therefore, fx is decreasing. Fx equals to x minus 1 whole cube into x minus 2 whole square, which is a polynomial function, of degree 5. Hence differentiable function. Now differentiate x minus 1 whole cube into 2 into x minus 2 plus x minus 2 whole square into 3 into x minus 1 whole square. Now here x minus 2 into x minus 1 whole square. So 2x minus 2 plus 3x minus 6. So here x minus 2 into x minus 1 whole square, 5x minus 8. We take 5 common, x minus 1 whole square, x minus 2 into x minus 8 by 5. Now we take a number line. Minus infinity plus infinity. It is 1, it is 8 by 5, and it's 2. Now plus for all sign changes, sign immense changes. Now where it is increasing, we can say for all x belongs to minus infinity comma 8 by 5 union 2 to infinity f dash x greater than equal to 0. Therefore, fx is increasing in this interval. And for all x belongs to 8 by 5, comma 2, f dash x less than equal to 0. Therefore, fx is decreasing. F of x equal to x cube minus 6x square plus 12x minus 18 is increasing for all x belongs to 1. So we can see that fx is a cubic polynomial. So fx is differentiable function. So fx is differentiable function. So f dash x equals to 3x square minus 12x plus 12. So 3 into x square minus 4x plus 4. That is 3 into x minus 2 whole square. That is greater than equal to 0 for all x belongs to R. Therefore, fx is increasing for all x belongs to R.